Stuck on CNA labs? Tired of scattered tutorials? This full course covers every exam topic with real lab configs. Grab your free lab in the description. Ready to pass CNA and boost your career? Start now!
Hello everyone, I'm your instructor Sunlibo. In this lesson, we'll mainly get to know the network. As a network engineer, you need a clear understanding of the network. After completing this lesson, you should be able to understand what devices make up our network, and what the characteristics of these devices are, their advantages and disadvantages, what kind of scenarios they are applied in. This lesson has two main parts. The first is to define what a network is. The second is to get to know, as network engineers, the devices we mainly work with in our daily jobs. Let's start with the first part. The first part is what a network is. Network itself is a very broad concept. The network we refer to here specifically means a computer network. So what is a computer network? We say it's some independently functioning computers. Multiple such devices, and their peripheral external devices, connected through some communication cables, forming such a mesh structure. This network is what we call a computer network. In other words, a computer network mainly consists of two parts. The first part is our independently functioning computers. The other part is the communication cables. This lesson focuses on explaining the independently functioning devices. Here we will talk about some network devices. These are devices we encounter in our daily work. First, let's determine why we need network devices. If I only have two computers, and I just need to transfer some data between them, in this case, we can actually just use two cables. Or one cable is enough. Plug them into the network ports of the two computers. In this way, they can actually communicate directly. No network device needs to be added. But in our actual situation, in the vast majority of environments, we have many devices. And also to consider future expansion. Right? Our network cannot stay like this forever. The network could grow larger in the future. In that case, if we still connect one device to another directly with cables, using this method, you will find if you have many devices, you need to connect every pair. Then, on a single computer, you would need many network interfaces. Right? So, we introduce some hub-like devices. They consolidate all these cables. All are centralized. Right? Each computer only needs to connect to this one device. Through this device, traffic, I can then access many other devices. Just like, this is the main purpose of our network devices. The current mainstream devices, and those we use most at work, are roughly these. Of course, ignore the first one. The first is a hub. Its function is just as I said. We connect all network cables to this hub. Right? When I need to communicate with someone, I access them through this hub. That device is then reachable. Right? It's like taking all cables from and twisting them together. All communicating computers have their cables twisted together. Access all devices through this single cable. Of course, the devices we mainly use now are the following. The first very important device is our switch. The second one is our router. Routers and switches. Right? And also some wireless related devices. For example, our wireless, we call it AC. And what else? Like our wireless access point, we call it AP. Let's look at them one by one. Hub. As for the hub, its function is very simple. It simply takes these cables and concentrates, and then, the corresponding network cables. Right? Generally, we use network cables to connect computers. Right? There are 8 pins on a network cable. 8 pins. So the hub's function is to connect these 8 pins together. Connect them together. It's just like wiring electricity at home. Right? Wiring during renovation. You just twist the live wires together. Twist the neutral wires together. And twist the ground wire. In this way, everything is connected. Right? So over here, it's this. A hub twists the 8 wires inside the cable together in pairs. At this point, the structure it forms, or rather, once this cable is connected out, there might be many network cables outside. Right? But these network cables, from an electrical circuit, they are the same entity. When an electrical signal, every line will carry this signal. So this type of network, we call it a shared network. It cannot support multiple people accessing it at the same time. What does that mean? When you are transmitting a signal into this cable, if someone else also tries to transmit a signal into it, then the 2 electrical signals will collide right here. Right? The connection will be broken here. And access becomes impossible. You must wait for one person to finish all communication. And then the rest can queue up to continue transmitting this data. Otherwise, you just have to wait. Just have to wait. So this device, the hub, as our network technology developed, was gradually phased out. Basically, you cannot see this hub device anymore today. But as part of the development process of computers, I still need to explain it to you. Okay. So here is what we just mentioned. When we transmit data through a hub, you send out a signal. Right? Then all cables connected to this hub, or devices. Right? Then between them, collisions will occur. Such a scope, we call it a collision domain. In this shared network, if you send out a signal, collisions will occur. In this structure, this area, we call it a collision domain. In such an environment, we need some detection mechanisms. For example, our collision detection mechanism, right, used to prevent data packet collisions. This collision domain, currently, this mainly occurs on hubs. For our higher-end devices, like the switch we will learn about later, each of its interfaces is independent. Therefore, each interface on the switch will not collide with another. There are no collisions. They can transmit data simultaneously. So, let's learn about what a switch is. What is a switch? It has more interfaces than our hub. Right? As we can see in this diagram, this is a 48-port switch. Right? Of course, there are models with fewer interfaces. There are also fewer. However, generally, a switch has a relatively large number of interfaces. Relatively many. Now, these interfaces. For example, on a switch in our diagram. Right? It has 48 interfaces inside. Each of these interfaces is independent. Every computer connected to these interfaces can simultaneously send or receive traffic. Receive these packets. This is completely fine. Therefore, generally, in our current enterprise networks, switches have a larger proportion. When you go to work, when you do projects, basically over 90% of the devices are switches. First, because its interface count, the density is relatively high. Similarly, a device like this, your router might only have 2 or 4 ports. Right, but a switch can have 48 ports. Or even more interfaces. So its port density is, for example, when your employees, when their computers need to connect. At this point, if you use a router to connect them, right, one router might not connect many computers. Right, but if you use a switch, one switch can connect many. So, the switch, its first primary function, is to connect our end users. This device connects end users. Since its main function is connecting end users, the computers we have below are the so-called end users. Right. So these computers, they might cause some damage. These things, it's not that they aren't, right? Sometimes, for example, there are some worm viruses in the LAN, right? Which could potentially cause network attacks. At this point, we can, on the switch, enable some basic security features. The switch can have these too. Most switches have them. Also, there is a concept called broadcast domain isolation. Broadcast domain isolation. As for broadcast domains, I will explain them in detail later. What is a broadcast? What is a broadcast domain? Switches can divide the broadcast range, which is broadcast domain isolation. What about switches? Their advantages are outstanding. They can provide access support for multiple users simultaneously. They also support full duplex. Currently, our mainstream devices all support full duplex. Half-duplex devices are old equipment from decades ago. Right? What do full duplex and half-duplex mean? Full duplex means you can simultaneously, at the same moment, have traffic in both upload and download directions. You can handle both simultaneously. What about at the same moment? You can only upload or only download. It's like a two-lane road versus a single-lane road. Right? Cars can either go one way or come the other way. That's half duplex. That's how things were a long time ago. Currently, all our devices support full duplex. They can handle upload and download simultaneously. Since switches are so excellent. Right? Do they have any disadvantages? Yes, switches. Generally speaking, our mainstream switch come in two major categories. It depends on their interfaces. One type is called electrical. We plug in Ethernet cables, transmitting via electrical signals. We call these electrical port switches. The other type is called optical port switches. We plug in optical modules, connected with fiber optic cables. Connected with fiber. Besides these two types, some of our internet dedicated lines. For example, with carriers. Right? You sign some agreements. You pull a So, in the early days of the internet, for example, these dedicated lines used serial ports for connection. Not the familiar RJ45 connectors or fiber optic transceivers. Right? To connect with us, it used a serial interface. This serial interface, the port is quite strange and very large. Right? So this kind of thing cannot be plugged into our switch. That's when we need another device, which is our router. Routers have dedicated modules for serial interfaces on leased lines. They have specific modules and ports for that. You can use it to make the connection. Therefore, a switch can handle the vast majority of use cases. That's also why, when we build an enterprise campus network, the vast majority of devices you see are switches. Okay. So this is our typical enterprise level topology diagram. What is a topology? It's the logical structure of our network. Logical structure. Generally speaking, a network, based on hierarchy, can be divided into 4 layers. So, the first layer, the one at the very top, we call the egress layer. What is the egress layer? It's easy to understand. It's the exit point from this network. Right? So, the egress layer here, its main function is to connect to our WAN, meaning it interfaces with our ISP circuit. Whether you use dial-up, static IP, or a dedicated line. Right? You have various solutions. In that case, you need an egress device like this. These devices are either routers or firewalls. This is our egress layer. Further down, we enter the switching domain. Like our core layer, distribution, and access. These are all our switches. Each of these layers has its own independent functions or focus areas. They differ. Of course, not every network needs all these layers. As we progress in our studies, the network scale will grow. At the beginning, you might only need one switch. Gradually, you might need 2, 3, or even more. Eventually, we will study a topology like this. This kind of topology can already solve the internal network structure for small and medium-sized businesses. You can address it with this. Okay, so after completing NA, after completing the CC, this is the skill you will master. Okay, regarding Cisco switches, the current mainstream models, you should have a general understanding. These models, the mainstream ones are the C9000 series. We also call them CAT 9000 series switches. It's divided into 92, 93, 94, 95, 96. These series of switches. This number designation is the larger the number, the stronger its performance. Of course, the price will also be higher. So it's not that a certain type of device must be an access switch, or must be an aggregation switch, or a core switch. Not necessarily. This mainly depends on your budget. If you have the money, you can use 94, 95, 96 for access switches as well. Right, if you're a big spender. Anything goes, right? Generally speaking, what we usually follow is that access layer switch, their main role. Let's go back a bit. The access layer is at the bottom, right? Its main role is to connect our users. It doesn't have many complex features. Moreover, the traffic generated by each computer is actually limited. For example, a 24-port gigabit switch. Each port might be 1G, right? 1 gigabit of traffic, right? Then, with simultaneous upstream and downstream, right? One port handles 2G of traffic. That's the absolute maximum, right? There won't be much more traffic. Therefore, access layer switches don't have high performance requirements. Performance requirements are not high. So generally, we use some lower-end switches, like the 92 and 93 series. Catalyst 9200, right? Or 9003, these two models. As for models like 9400, 9500, 9600, these devices, their performance is relatively stronger. They might have some 10 gigabit interfaces, or even 40G interfaces, even some higher-end interfaces. And higher speed interfaces are available. This mainly depends on your traffic volume. Also, your budget. These are all related factors. Just have a general idea about this first. So this is the Catalyst series. Cisco's enterprise-grade equipment. It is all named using the Catalyst brand. Like our Catalyst series switches. That's it. Then there is the Meraki switch. As for Meraki switches, they are mainly used for small and medium-sized portable office networks like this. Some Soho environments, right? You might only have a few workstations. So these relatively small micro-enterprise networks, you can use Meraki for these, because it has cloud management capabilities. But configuration is different from traditional enterprise switches. The networking approach is different. In our CCNA course, we generally won't cover learning about Meraki, because it's quite different from traditional enterprise networks. Then there are some designed specifically for small businesses, right? Besides this Meraki switch, right? There are some others. For example, the Business series. Also, the Catalyst 1000 series. The model numbers are very small, right? Also, the 9200CX. These high-density portable switches. These are also available. Yes, also, generally, in enterprise networking, these are quite rare. They are quite rare. These compact switches, they are relatively small. They might be suitable for home use, right? Then there are switches for data centers and cloud computing. This is a different product line. We call this product line Nexus. The Nexus series. The relatively new ones. That's the Nexus 9000 series switch. The highest-end Nexus 9000 series switch is 44 rack units tall. That's over 2 meters high. A single switch. Over 2 meters tall. About 60 and over 40 centimeters wide. It fills an entire rack cabinet. Just one switch. This is a very powerful switch, right? Of course, the price is also very impressive. We also have the Nexus 3000 and Nexus 3550. These switch series are used in our data centers. Just buying the chassis for these devices can cost millions or even tens of millions. Okay, these are some of the Cisco switches you might come across in your daily work. This is their product. Just get a general understanding for now. Of course, within these series, they vary by different specifications. For example, within the 9300 series switch, it comes in 24-port and 48-port versions, right? Also, it has uplink ports. For instance, 10 gigabit or 40 gigabit uplinks. Right? And whether it has PO functionality. All kinds of configurations are possible. It really depends on your needs. Specifically, check its datasheet. Look at its spec sheet to know what specific interfaces this switch model has, and which features it supports. During our switch discussion just now, we mentioned that a switch can segment broadcast domains, right? So, what is a broadcast domain? What is a broadcast? Let's first understand that. These actually refer to our transmission methods. When transmitting a packet in an IPv4 network, there are 3 transmission methods. Don't worry about IPv4 for now. It just means when you send a message. There are 3. The first type is unicast. Unicast means one-to-one. One-to-one. Just like in our daily life. Within our SIBO. Between the teacher and the class advisor, right? They often say to you, "I'll unicast you." What does this mean? It means I'll private message you. This is very similar to our chatting. Very similar. So-called unique is a one-to-one private chat between me and you. Right? A one-to-one private, then multicast. What is multicast? It's one-to-many. But this many has a specific direction. It's not just defining a random range. Right? Multicast is one-to-many. For example, we take the students in our class, right? We pull them all into a group. Then we communicate within the group. This is what we call multicast. That is multicast. All my messages are in this group. Right? Sent within this group. As long as you are in this group, you can see this message. You can see this message. This is multicast. It is not for everyone. Right? It is only for a specific group. A specific group. I send out one message. And this group will all receive it. People not in this group will not receive it. This is called multicast. Then, what is broadcast? What about, it's like you take a mega, right? As long as it's within range. Right? The sound. Wave, right? The range it can reach. All of them can hear it. All can hear it. So-called broadcast targets all. We call it one-to-all. One-to-all. So, back to the concept of broadcast domain. What is a broadcast domain? It refers to sending a broadcast message. And the range it covers, that range is called a broadcast domain. It is called a broadcast by default. By default, all interfaces on a switch. All interfaces are in one broadcast domain. Are in one broadcast. Okay, now, imagine, if I have 1,000 terminals to connect in the LAN, then I might need hundreds or dozens of switches. Right? Yeah, dozens of to connect them all. Yeah, to connect them all. Oh, these switches are interconnected. Right? Then, one of your computers sends a broadcast message. By default, one interface. All interfaces on a switch are in one broadcast domain. That means a broadcast message enters. And from other interfaces, it will be sent out. Right? Okay, so in this situation, then all your hosts are in one broadcast domain. When a message goes in, all computers will receive this broadcast message. Will all receive this broadcast message. So in that case, all computers are in one broadcast domain. Right? So in that case, if everyone keeps broadcasting, then no one can get any work done. Right? It's like our classroom, right? If there are 1,000 people and everyone shouting with a megaphone, right? Then the teacher can't teach. Right? So the broadcast domain should not be too large. Generally, we want to make this broadcast a bit smaller. To segment this broadcast domain, this is also a feature of our enterprise-level switches. We can use some logical commands. Right? We use some commands to take these interfaces and isolate them into different broadcast domains. For example, I can take ports, right, and assign them to one broadcast domain. Then ports 13 to 24. I assign them to another broadcast domain. So in this, when you send a message, it only affects those 12 interfaces and does not affect the other interfaces. Right? So we can artificially limit the scope of these broadcast domains. Make it small. Make it okay. This is what we mentioned earlier. The concept of a broadcast domain. Now the switch, as we just has a PO function. Right? What is PO? In enterprise networking, this is very important. Very important indeed. So-called PO stands for Power over Ethernet. What does that mean? It means delivering power over network cables. Delivering, because our network are essentially copper. Right. Copper wires can transmit voltage. Right. So in some, with devices that need power. For example, mainstream IP phones. right. Also, surveillance cameras. Access right. And all, like APs. Wireless APs. These devices, besides needing a network cable, also need a power supply. Right, to power them up. So if we support PO, if the switch supports PO, then I only need to connect one network cable. This cable can transmit our signals, transmit our data, and also provide power to these devices. This is called PO functionality. Simply put, it's a feature that supplies power over a network cable. So generally speaking, we, for access switches in an enterprise, a few of them, we will configure their PO. That is, when you purchase a few switches, you need to buy ones with PO functionality, with PO support. Because in our enterprise, there are always some devices that need PO power. Of course, you don't have to buy them. You can buy a separate power supply for each device. Right? Buy this adapter, a power adapter. Connecting it works too. But then you have to, for example, take our cameras, right? You mount them on the ceiling. Then you have to, at that corresponding location, you have to install a power, otherwise you can't plug in the power. Right? And telephones, you have to plug all these things into power. That's very troublesome, right? Very trouble. So using PO during implementation, during cabling, makes it much, and then, during network setup, it's also simpler. This is, a mainstream technology we all use. Just understand this, okay? So that's basically it for switches. That covers we'll learn later how to configure these switches to meet enterprise needs. The third type of device is called a router. Now, this thing called a router. Everyone has one right? But the router you have at home, well, is a consumer-grade device. It's quite different from an enterprise-grade router. This enterprise router, its primary function is to connect to the WAN. It connects to the ISP. The ISP might hand off a line to you. Right? This line could be an Ethernet, or it could be a fiber optic cable. It could also be a serial cable. Right? It could be other types. Right? Anyway, you'll get a line. At this point, we need a router to connect with it, to interface with the ISP. Now, this router, won't have a huge number of ports. Of course, now, the market does offer some routers with integrated switching. They're routing and switching all-in-ones. Right? It's not an absolute that this route has very few ports. Not necessarily. Now there are also hybrid devices emerging. But generally speaking, routers have relatively few interfaces. Its main role is to connect to our WAN and also interface with our internal switches. It acts as a connecting link, bridging internal and external connections. We usually place routers at the egress layer, and we often call it an egress router, or simply an egress device, called egress, or something like that, right? That generally refers to our router. Using routers, we can build large networks because they support routing protocols. They support route and offer higher security. Higher security. If you need even higher security, you can use a firewall. Right? Of course, firewalls are in our security course. Generally, for small and medium businesses, using routers is quite common, because using a firewall requires operational skill, right? And the cost is relatively higher. So that's the router. It can be used to build large networks. And its security is relatively high. What about its interface count is relatively low. Moreover, the price will also be higher. For example, if I have a 24-port gigabit switch, if it's from Huawei or H3C, it might only cost a used one might cost less than $1,000. Right? As for routers, if you need to buy one, it will cost at least $1,000, right? The stronger the performance, the more expensive the price. Moreover, the router connects to our external network. That is, it connects the line coming from the WAN provider, right? This also relates to your external network bandwidth. For example, some enterprises might install a gigabit or even a 10 gigabit line. At that point, your throughput will be very large. All your traffic needs to pass through this exit router. For forwarding, So the performance requirements for the router are also very high. Cisco's mainstream routers include the Catalyst 8200 and 8300, right? These are what small businesses might use. Also, there are routers from the ISR series. Meraki is the same. It is the same. It targets micro-enterprises. This kind of Soho office environment. As for carrier-grade routers, these are much more powerful. Like the device in the middle of our diagram, right? This one stands very tall. Devices like this are the core equipment of providers. Like China Telecom's. China Telecom's core devices all look like this. You can spot them at a glance in the data center. Of course, due to some policy restrictions in China. Between providers like China Telecom and China Mobile. They will not purchase Cisco equipment, right? But if you work on some projects involving foreign enterprise which require high-performance forwarding, then you might encounter them. Okay, these are some router models. Just have a basic understanding of them. And here is the broadcast domain we just mentioned, right? So by default, all switch interfaces are in the same broadcast domain. However, a router, each of its interfaces is a separate broadcast domain. A broadcast message enters one router interface, but it won't come out of the others. So by default, if you don't configure this device at all, switches, routers, none of them are configured. And you just connect routers like this. As we're doing now. A router sandwiched between two switches. Then the switches connect to our devices. Right? With this connection method, it naturally isolates our broadcasts. It can isolate our broadcasts. Right? Of course, this approach is too low end. Right? Too low. We can use configuration to achieve more advanced requirements. But keep in mind, we are referring to the default behavior here. Default behavior. We can change it, right? Enterprise-grade devices can be modified via command line. Okay. Then what's next? There are two are related to wireless. In this course series, wireless content is relatively limited. It's more of a general introduction for you. So if you are more interested in wireless, we will have a dedicated wireless module later. To explain it to you, let's look at the first device, called the wireless controller. We also call it AC for short. Actually, this AC thing is not mandatory when building a wireless network. Right? It doesn't necessarily require an AC. If your wireless network is relatively large, then at this point, you will generally see this AC. Because it can help save costs. AC, what is an AC? It's called a controller, right? So, what does it control? It controls our wireless access points, called APs. It controls our APs. So the controller's primary role is to manage our APs. It also lets our APs manage radio frequency signals. For example, your channels, your signal strength. All these can be uniformly allocated by the AC. Uniformly allocated. It also provides some access security authentication. These policies and related things. Just like when you access a wireless network. You need to right? These things are all handled, they are managed by the AC. It also supports roaming. Roaming, for example, if your house is large, right? It's a villa. You walk from the first floor to the second, third, then fourth, right? You go floor by floor. Or run around in the yard. At this point, one wireless router definitely cannot cover everything. You surely need several, right? Switching between different routers is what we call roaming, right? These things can also be managed by the AC. It makes your roaming more seamless. Pay attention when hopping between routers. Your phone, right? Connects to the first router. Then, as you walk, it gets close to the second router. Your signal then switches over to the second. We call this process roaming. During the roaming process, there will definitely be a period of time when latency is higher, or even packet loss might occur. It will definitely, just a matter of how long it lasts. For example, using an AC. This time can be as short as under 50 milliseconds. Can be as short as under, basically, it's imperceptible. So, when you are using, or when you are playing a game, right? Playing on, or at this moment, as you walk, you might suddenly feel for a moment the ping value, and then it immediately, that's the kind of that's one of the benefits of using an AC. And this is also one of the features of wireless networking. Just get a general understanding for now. So, the AC. The wireless controller. Using it, its advantage is that it's more suitable for building large-scale wireless network. Its roaming capability is quite strong. For example, places like train stations and airports. And also, commercial shopping centers like this. The entire venue, right? The entire site is very large. Within this environment, there will be many wireless routers, all needing management by the AC. Right? With this in place, you have a commander-in-chief. Right? It's like having a brain to manage these devices. To manage our wireless devices. This is quite impressive. Then, of course, it has its drawbacks. If your wireless network is relatively small, like your home, maybe around 100 square meters, the wireless routers maybe only 3 or 4, right? 3 or 4, in that case, using an AC isn't very cost-effective. Because a wireless AC, the AC is quite expensive. Easily tens of thousands, right? Then you add 3 or 4 small APs. Right? The cost becomes very high. You'd be better off buying a slightly more powerful wireless router. Right? Buying 4 independent ones also works, right? 2,000, the total might be only, right? The cost would be, so, this AC thing is more suitable for large networks. Your network scale, the larger the wireless network scale, the more cost it saves. Of course, each AC can support the APs it can manage. Has a quantity limit. It's not unlimited, right? But, if the scale is truly too large, then you just add another right? The devices it can manage will increase again. So, this AC thing is for heavy lifting. It doesn't take small jobs. Don't use it for small jobs. Now, regarding the AC models. There are roughly these types. Basically, it's the Catalyst the 9800 series. Within the 9800 series, there is a CL. It is a virtual device. That means it's a virtual machine. You can, on your computer, use virtualization software like VMware Workstation to run it. So you don't need to buy hardware. This is quite convenient. You still need to purchase the license. The authorization stuff still needs to be bought. Just no need to buy the physical box. Right? The physical, firstly, secondly, its delivery lead time is, right? So, very often, we will adopt this method. Use virtual devices. Okay. Then, a very important thing in wireless, wireless access, so, what everyone uses at home is called a wireless router. Right. In your home, we call it a wireless, now, in enterprise level app, we call it an access point. Right. So, its main function is to transmit signals. Correct? And to connect our wireless terminal devices. Right. Like your desktop, laptop, that sort, right? Also, all your smart devices at home. Correct? All these connections count. This is the main job of an AP. It's simply a signal, and then it connects your, connect devices. Now, regarding these APs. When we use them, they come in two main, one is called a FAT, the wireless router in your home actually falls into this, can be configured independently. Can be configured independently. At the same time, when installing it, it is also quite, it's relative, okay, there are no requirements for interaction with the AC. You can just connect them, as long as they can, This is a FAT AP, it can be configured, each device, for example, if you set up 4 routers at home, 4 wireless routers, you can configure each one individually. This is the so-called FAT AP mode. Okay, the FAT AP mode. Then there is another called FIT AP. For FIT APs, compared to FAT AP, they cannot be configured independently. No, they cannot be configured, the AC must configure them centrally. So all configurations on this FIT AP are pushed down from the AC. Okay, you are just a signal transmitter. Just an end, you can simply understand it that way. All the computational processing is on our AC. All on the Therefore, compared to FAT APs, FIT APs are cheaper in price because its functional requirements are simpler. Right? Okay, they don't need very complex computing components. Use chips, these things will be cheaper. So the unit price of a FIT AP is lower. However, if you say add this AC, right? Then the price will be different. The price, so at this point there is a threshold. There is a threshold you need to calculate. When the number of your show APs reaches what point? Then, it's recommended to use this AC plus AP combination. Right? For example, you buy upon AP. 5, and a show AP, 200, I'm just giving giving it, okay. So at this point, upon AP, 500 yuan each. Right? Okay. And the show 200, okay. And the AC, we just mentioned this AC, right? As for the let's assume, hey, 10,000 yuan, 10,000, now let's calculate. If we need 100 of them, 100 PUN, the price is also easy to calculate. Right? So this one is 50, And if I use show AP, it's also, right, so the cost for its AP is 20, right? So what about the AC? It's 10, now you can calculate, hey, AC plus show AP, 200, 100, right? So its cost is, but if you use PUN AP, hey, it's, the cost will be, and also, for 100, managing each one individually is very right? So here, you can write a formula. Right? This, hey, should be a linear equation. Right? You can write the equation calculate this right? How many units exactly? This thing, it's best to recommend using AC plus AP. Right? Because different AC models and AP models have different prices. Also, as time changes, as time goes, the price will change too. It will change, so this thing, I can't give you a unified answer. You still need to calculate this yourself. Calculate the cost right, okay. So, from this point, you can also see, from this point, you can also, that our, show A, right? Its cost is relatively low. PUN A has a relatively high, but it can be configured in, then its drawback corresponds accordingly. PUN A has poorer scalability. Its expansion units are added independently one by one. Right? Management and maintenance costs are also higher. Right? It would also be as for show A, it needs to be managed by the AC. Right? So, for small-scale deployments, the cost will be, these are our wireless APs. These common models, of course. There are many other supporting points in wireless. For example, our APs are divided into indoor and outdoor models. Right? Like in some squares. On utility poles. Right? You can see some wireless devices. Mounted, some have some might not. Right? These are likely outdoor APs. Some are base, right? Base stations for cell phone, those also exist. As for these models, the most mainstream ones are our enterprise-grade indoor units. The most mainstream is the Catalyst 9100 series. The 91, as for the others, generally, they don't concern us much. The 9100 currently supports Wi-Fi 6 and 6E. Enhanced 6, right, Wi-Fi 6, like this. AeroNet. This AeroNet series supports Wi-Fi 5. It supports Wi-Fi, You can choose according to your needs. Right, consider this during model selection. Like the following. These models. These are mainly for outdoor use. Also, for some industrial purposes. Like on the production floor. There might be high temperatures. Or high humidity, right? Humidity, or there is dust, right? This differs from our indoor office scenarios. Requirements differ, right? It might need to be waterproof, dust-proof, a ruggedized design. Just be aware of this for now. Okay. These are what we just mentioned. All network device icons mentioned earlier. These icons. Because in daily communication, we don't paste such pictures. Or, to quickly explain a technology, I might sketch a hand-drawn diagram. During that process, you need to master. This is a rough idea of what these device icons look like. You should be aware of this. For example, during my how do these two devices connect, right? Then I draw it manually for everyone. Right? As for hubs and those things, we generally, won't use them, right? The most common is the switch. There are two ways to draw. One is rectangular, and another is square. As for the difference, we'll explain it to you later. As for routers, when we draw, it's usually a circle with an X in the middle. Right? For example, 2 routers, so I connect them like, right? 3 I might connect them like this. Right? For router, I might connect them like this. And then, for example, there's a switch at the bottom in the middle. Then I might draw it like this, right? Hey. This is just when drawing some diagrams. You can get familiar with it. Okay. And then the PC. Right? So this is just a simple illustration. 1 person, 1 monitor. And then, what about the other stuff? We rarely see them during our studies. What you need to master are these 2 images of switches. And then, router, right? What else? PCs. These, in our CCNA studies, we will use them all. Yes, we will. You need to have an impression of them. Okay, when I draw them later, I will explain, right? You need to be able to react. When I say PC, say router, say switch. Alright, okay. So, let's summarize. In today's class, I mainly introduced you to some devices in our network. Okay, network devices. Like our hub, switch, router, right? Access control, wireless control, access point, wireless access point. Right? And you got to know these devices. And their main uses. What else? Some of its pros and cons. Right? Okay, so that's the content for this lesson. That's all.